All right, logarithms and exponential review. So this is the paper test, and there's no graphs on this. So the way I'm doing the graphs is if you look at the bottom of this, once you do this quiz test, there will be a 4-point test as well. There's 5 questions online on Khan, and I'm going to give you points. I'm a grade out of 4, so the highest score will be 4 you can get out of this. So plus 4 points to complete the Khan Academy quiz for exponentials and logarithms, and get at least 8% for full credit. That's the 4 out of 5 that I'm referring to, and that's the quiz 4. It's graphs, so make sure you do the graph 1 for credit here, and we also do this in class when I'm observing you, so I can tell you're not cheating in some way. Okay, so for the paper test, we have log of 64 with base 4. So the question reads 4 to what power equals 64? The question is, or the answer is 4 to the 3 is 64. So that's the answer there. All right, next question. Same setup. 27 to what power equals 1/3? All right, well, we don't have the same base, so let's try and convert these bases to the same base. This can be rewritten as 3 to the negative 1, and 27 can be rewritten as 3 to the 3 times our original x. That has not gone anywhere. Now we can cross off our 3's, and we have a simple algebra problem remaining. We divide both sides by 3, and we get x is equal to negative 1/3. All right, rewrite in exponent form. So all we have to do is do this, but instead we have an answer. So this was x. Well, now we have an answer. We know it's 1/2. So it's going to be 49 to the 1/2 is equal to 7. We're going backwards. We will write this in log. So our base is our base of log is 8. Our log always equals our exponent, and our last number goes in here. So log of 16 with base 8 is equal to 4/3. All right, rewrite as a single logarithm. So this is where we have to use some properties. One property we can use is the power rule. Bring this 2 inside. So it becomes log base 4 squared plus log base 4 of 2. 4 squared, 16. And then we have an addition of 2 logs with the same base. That's very important. We can multiply these numbers, so we get 16 times 2, which is 32. So log base 4 of 32. And that's that. Evaluate to the nearest thousandth. So we can do one of 2 options here. I'm going to do the way it reads directly and not using any property rules. Well, I guess I'm using change of base here. So I'm going to do log of 644 with base 10. Over log of 8, also base 10. And I'm going to multiply all this by 3. So I went forward and miscalculated in my calculator. So I'm going to have to come back. So I'm back at, put this in my calculator. It's log of 644. And I'm dividing by log of 8. That's actually my mistake. I didn't hit divide. I tried to, but I just missed it. And I didn't notice until later. So I get 3.1103, and that is times 3. Oops, and there we go. So it's 9.3309. That 0 can round up to 1. So the answer will be 9.331. Okay, now the other way I can do it, I already started doing it because this is actually how I found my mistake. Up here, I got a different number. So I can also move this 3 to 644, and it's called the power rule. And so if I do my calculator, let's just do 644 to the 3. It's a really large number. So instead of doing that first, I'm just going to put my log, and we're going to do 644 cubed, divide by log of 8. And we get 9.331 as well. Okay, next question. Rewrite as a single logarithm, very similar to this problem up here, except we have a variable in here. We can't combine these two directly they're different. So what we want to do is rewrite these with a change of base. So log of 18 with base 10 over log of a with base 10 times log 3 and log 18. Well, it cancels out. These log 18s cancel out. We're left with log 3 over log a. We'll use the change of base rule. We can rewrite this as log big 3. Our denominator becomes our base, and that's our answer right there. Okay, approximate the value of t to the nearest thousandths down here. So we want to isolate the t, so we got to move everything away from it. So we're going to first start with the 11, so we're going to get 10 to the 5t. And we're going to divide both sides by 11. So those cancel off. Equals 20 over 11. The next thing we want to do is to get rid of this base, so we can make this t bigger, is take the log of base 10, that's the base right there is 10, and we can rewrite it as 5t is equal to log base 10 of 20 over 11. And our final step is to divide both sides by 5. So t equals log base 10 of 20 over 11 all over 5. That's just approximate the value up here. So we need to put this in the calculator now to give the exact equation or the exact answer. That'd be the exact answer. So log base 10, we have 20 divided by 11. Sorry, I put it on the screen. And we're dividing all that by 5. So divide by 5. We get 0.0519. That 9 rounds that 1 up to a 2. So 0.052. Okay, question 9. Very similar question, but we have a different base. And 10 is the same question as well, just different base. This one I guess we have to do change of base eventually, because this one we can use our natural log button. So this is very, very similar to the last question, just we have to use this button instead of the log base 10. So we're going to first move over to 17. So we get 12 over 17. So we divide it by 17 on both sides. Then we need to take log base of e, which can also be rewritten as ln. Remember, these are the exact same thing. So this side crosses off. We get negative 7t is equal to ln of 12 over 17. And then we're going to divide both sides by negative 7. So we get t is equal to ln 12 over 17 all over negative 7. So use the calculator, 12 divided by 17, close that parenthesis, and divide by negative 7. And it's 0.0497. That 7, once again, moves this 9 up, which also makes that 5, or that 4 go up. That's a 0 now, so this becomes 0.05. Question 10. Approximate the value of t to the nearest thousandth. So divide both sides by 8. Let's see if this is a whole number. 43.25, so it's not. We're going to leave it as a fraction. 3 negative t over 9 equals 346 over 8. Take both sides of log base 3. We're left with negative t over 9 is equal to log base 3 over 346 over 8. And finally, we're going to multiply by negative 9. I have a feeling that negative sign is going to be where most of you get tricked up. You're going to forget that negative sign and get the answer slightly wrong, which I still do give partial credit. I will notice that mistake and give you credit for what I think you deserve. Times negative 9. All right, so now we have a base that's not 10 or natural, so we have to use change of base. So we're going to do log of 346 divide by 8 over, close that off, and then divide by log of 3. And then we're going to times that all by negative 9. Which gives us negative 30.859. That rounds that up, and that rounds that up. So it's negative 30.86.